Hello everybody, let's talk about physics. I'm Danny.
I'm Peyton.
I'm Camila.
I brought my baby just in case we all have some.
Get in. We gotta teach about physics.
Work is a change in energy used to move an object a distance when both the force and the motion of the object are in the same direction. The formula for work is force times distance, and in this example, Peyton is pushing Camilla on a skateboard in a direction. The force she applies in that direction that Camilla is moving is the work of the system. Work is a change in energy and is also represented by the equation force times displacement, in which the vector of the force and the vector of the displacement is in the same direction. Work is not the same thing as energy, but it is a change in energy. If a person of mass 40 kilograms were on a skateboard and a person exerted a force of 4 newtons on the person of 40 kilograms, causing her to move 25 meters, then the change in energy of the work done on the person is 100 joules. If either force or displacement is decreased, so does work. If either or both force and displacement were to increase, so would the work done. Notice that the mass of the 40-kilogram person doesn't affect the amount of work done. If the person were to weigh more or less, as long as the force exerted and the distance traveled is the same, then the work remains the same.
Moving on, let's talk about spring energy. Spring potential energy is energy of a compressed or stretched string, stored as the result of deformation of an elastic object, such as the stretching of a spring. It is equal to the work done to stretch the spring, which depends upon the string constant K, as well as the distance stretched. The formula for spring potential energy is 1/2 kx squared. To give you for instance, as you can see here, Peyton is so effortlessly bouncing on this pogo stick, which contains a spring at the bottom, which allows her to gain momentum and bounce up and down.
Power is the work done over time of a system and is a scalar unit. It is represented by the equation W over T, in which W is the amount of work done in joules, and T is the amount of time in seconds. In the example of a person reeling in a fish, the work done by reeling in the fishing line over the amount of time it took for the fish to be reeled in is equal to the amount of power. If the amount of work done was to decrease, so would the power, and vice versa. If the time decreased, then the power would increase, and vice versa. Potential energy is a stored energy of an object due to its position relative to other aspects of the system. The potential energy of an object, h feet above the ground, with a mass of m, would have potential energy equal to mgh, where g would be the acceleration due to gravity. In other words, if an object, let's say Humpty Dumpty, who has a mass of 2 kilograms, were to be sitting on a wall with a distance of 5 feet above the ground, Humpty Dumpty would have a potential energy equal to approximately 100 joules, since the acceleration due to gravity is equal to about 10 meters per second squared. If the mass of the object, height of the object in relation to the ground, or the acceleration of gravity due to Earth would be changed, so the potential energy of the system proportionally. Kinetic energy is the energy of an object that is in motion. The kinetic energy of an object is due to the mass of the object and the velocity in which it's moving, represented by the formula 1/2 mv squared. The potential energy of a system will be equal to the kinetic energy of the system as long as there is no external forces acting upon the object. For instance, if Humpty Dumpty, who sat on the wall, were to have a great fall, the kinetic energy of the mythical Eggman would be the velocity at which it's traveling at that moment in time, squared multiplied by half the mass of Humpty Dumpty. After 1 second of free fall, the velocity of Humpty Dumpty should be approximately 10 meters per second, and the mass is still 2 kilograms. If the variables were plugged into the equation, the kinetic energy 1 second after Humpty Dumpty fell would be 100 joules. Since this amount is equal to the total potential energy after 1 second, Humpty Dumpty wouldn't be able to be put back together again with all the king's horses or all the king's men. If the mass of Humpty Dumpty were decreased, then the energy of Humpty Dumpty would decrease proportionally. If the velocity is increased or decreased, the energy of Humpty Dumpty would change exponentially.
And that concludes our video on work and energy.
In this video, you learned about work, power, potential energy, kinetic energy, and spring energy.